students, very good morning. In this class, we are going to discuss about machine learning life cycle. We all familiar that what is the life cycle, what are the things step by step process it is going to happen in a closed circle or to complete the process. It is called life cycle. Likewise, the machine also do have some step by step process. We'll see in detail in this class. Okay, the machine learning life cycle from data to deployment. So data is the raw thing, and coming to the deployment, it is the execution level. We just see the data to deployment. We have the 7 stages of process. The first one is, you see the image, the green color represents the gathering data and the blue data preparation, because we need to collect the data first, then we need to prepare the data, and data wrangling, that is the alignment side, we will match the data, then analysis, what are the data we took, we need to analyze, and the fifth stage, it is train model. Based upon the analysis, we need to train that data, and finally we need to test that model, then coming to the deployment. This is how the process takes place. The presentation unveils the core process of effective machine learning implementation. The UK ML market is valued at 3.5 billion dollar in 2023, drives innovation across the healthcare, finance, and retail. And coming to the data collection and preparation, data sources, quality focus, cleaning time, these are the major factors it could be considered. And data, coming to the data sources, gather data from data base, API, and IoT sensors. So how the data sources can be collected, as well as the we need to concentrate on the quality, that is quality focus, ensure high quality relevant data as paramount, as well as cleaning time. 80% of project time is for data cleaning. High quality data forms the foundation of any successful ML project. For example, gathering 200 TB of telemetry data is crucial. This ensure model, and this is the general reliability and prevent biases, because from this we can conclude the cleaning time, because whatever the data we are making and processing, and finally we are getting the output, it should be cleaned as per the schedule, and so that the next process will be happen very effectively. That is why here it does ensure the general ability, as well as the to prevent the bias. Okay, and coming to the data pre-processing and feature engineering, we have to pre-process before and after. You just check the image. We have to pre-process the data, what are the raw data it is fed, and finally it will be categorized or summarized or grouped or clustered based upon the machine learning, and according to its applications, according to its algorithms and formulae, it is grouped. Finally we can get the refined data like this. You just see the image mentioned here. And the transforming raw data into a model ready format is essential, because that is the case. And techniques like normalization, imputation, and outlier removal are applied. For example, we might use mean or meridian imputation also, because in machine learning applications and AI, this data collections, the mathematics is doing a vital role, and feature engineering can boost model accuracy significantly. For instance, creating an age feature from date of birth improve customer segmentations. This process enhances model performance by up to 15%. Model selection and training, because this mode is very important, because we need to select the perfect model, then we have to train. Without selecting the perfect model, if whatever we are doing the training, that is going to be wasted, right? So model selection and training, how the model selection process is happening, supervised learning, unsupervised learning, as well as the training data. And we can see the image here, how the model selection process happening: problem formulation, and candidate model selection, performance evaluation, and training and evaluation. Based upon this model selection process happening, then supervised learning, unsupervised learning, based upon that algorithm, it is going to be trained, and finally the refined data we will get will get as a outcome. Okay, choosing the right algorithm is crucial for specific problem types. Supervised learning like regression predicts continuous values. Unsupervised learning discovers hidden data, hidden patterns in data. Likewise, next, model evaluation and validation. So the next process, how we are going to evaluate the model as well as the validation. So here we can see the image model evaluation and validation process. Data preparation, that is train state splits. First process here, it comes the data preparation and train the data and test split, then performance metrics, cross validation, then coming to the model comparison, then coming to interoperability as well as the sensitive analysis. So this is how the model validation and evaluation takes place. The same case here, assessing model performance involves various metrics. For classification, we use accuracy, prediction, and recall. For regression, MSC and RMSC are key k-fold cross validation provided unbiased evaluation. So these metrics and detailed process will discuss while learning the algorithm in detail, right? And next, coming to the mode deployment, how it is going to be deployed. So RESTful APIs, cloud services, real-time predictions. So these are the three categories involved in the mode deployment. Especially in the machine learning mode deployment takes place the four stages: training, validation, deployment, and monitoring. Okay, so this is how the mode deployment takes place. And monitoring and maintenance, this is much needed. Whatever the data we have already deployed, without monitoring and maintenance, the process is not going to be complete, and also we will not have the efficient process. So here, continuous oversight, sustained value, detect drift, retrain models. So these four cases will be involved in the monitoring and maintaining process. And coming to the conclusion, iterative excellence in machine learning, because in machine learning the iterative process, it's very crucial, doing the very crucial role. What does iterative mean? Iterative is a repetitive. For example, we are combining the data as 70% and algorithm process as 30%, and we will get the efficient as 95% output. Then we need to collaborate as a 75/30, or the ratio should be alternated, and it will be iterated. Based upon the iteration, what about the outcome? This is how the process takes place. And ML is an iterative process needing continuous refinement. Successful implementation drive 20% efficiency gains. Exactly. Ethical considerations and bias mitigations are fundamental. Future ML demands robust, explainable, and adaptable systems. The machine learning life cycle is dynamic and iterative. Continuous refinement is key to success, because the continuous refinement will be done by the iterative process, right? Ethical consideration and bias mitigations are paramount for responsible AI, and future demands robust and explainable ML systems. So this is how the machine learning process it's happening from the stage, that is data collection from the data deployment. This is machine learning life cycle. Still now we have discussed. Thank you.